Here's an example in which we're trying to solve a triangle. They're giving us a reminder up here. Remember, even if you enter an answer rounded to a set number of decimal places, if you use that number in future calculation, don't use a rounded number in a future calculation is basically what it's reminding us of. Okay, so let's go on with this problem. The first thing we want to do is we want to draw the triangle we're talking about. So let's draw this triangle. So how do we do it? So let's just come in here and I'm just going to draw any old triangle, and this will be angle A, put B over here, put C up there. It doesn't matter. You could put A at the right and C at the top or bottom or whatever. It doesn't matter. And then across from those, I'm going to put little a over here, little b over here, little c over there. So notice we put C across from C, A across from A, and B across from B. That's how they assume our triangle looks. We have to do that. That's just the original assumption that they're all making on these problems. Okay, so little a, it tells us little a is 30 right here. Little a is 37.8 degrees. Capital A, angle A is 37.8 degrees, and little a across from it is 186.2. And little b, the side across from angle B, is 241.1. Okay, so the first thing they want me to do is they want me to find the sine of B. Sine of B. So, sine of B. So they're wanting me to use the law of sines, and B with B and A with A. See, now I'm going to definitely use A with A. Do you see why I'm picking that? Because I have both of those, don't I? I don't have B and B because I don't have this B, and I don't have either of the C's. But I have both of the A's, so for sure I want to use that. So come on down here. Step number one, I'm going to, let me just do little a over sine A is little b over sine. Remember, this is the law of sines, is little c over sine of c. This is the law of sines, that the fractions, the ratios of side over sine of angle are all equal, a over a, b over b, c over c. And you could flip that upside down and put the sines on the top. It doesn't matter. All right, so again, I'm going to use what? A with a. So they tell me 186.2. So little a here over the sine of capital A, the sine of 37.8 degrees, equals little b, which is 241.1, over the sine of B, right? Forget about C for now. Okay, they want me to get sine of B alone. So I'm going to go diagonal, diagonal. So I get 186.2 sine of capital B is 241.1 sine of 37.8 degrees. So, okay, so what do we do now to solve? Let's divide by the 186.2 on both sides. And so what do we get? Sine of B equals, I'm going to use my calculator. Make sure you're in degree mode, because everything's in degrees here, right? I'm getting 0.793619. So that's probably enough digits right there. So I mean, now they want me to give just that answer first off, right? Here they say, what's the sine of B? Oh, round to 5 decimal places. Okay, so 0.79362. It was 3619, so 362. Next, it's going to tell us there are two possible angles B between 0 and 180 with this value for sine. Find the two angles and report them so that B1 is the acute angle. So now step 2, this is a more advanced problem here. Step 2, find two options for B. How do I do that? Well, let's bring down the sine of B is 0.793619. And to get, I want to find B, right? So I got to get rid of that sign. What do I do to get rid of that sign? Do I divide by the sign on both sides? No. You know, I hope by now that you can't do that. You can't divide because that's not multiplication. Sine of B does not mean sine times B. It means sine of B. It's a function. So how do you get rid of the sign then? You do sine inverse on the left side, and of course, whatever you do to one side, you have no choice but to do the same thing to the other. See how this cancels and gets B alone? Sine inverse is the opposite of sine. It cancels it out. Okay, so then sine inverse of our 0.79 thing, I get capital B is 52.52503. I'll round to 5 places, degrees. But there's two options for B. That's the acute angle, meaning acute means less than 90. That's the angle less than 90. The other option, now here's the trick. The other angle, the one that is obtuse, the obtuse angle, obtuse means more than 90. The obtuse angle for B, so we'll call this B1, B2, is going to be 180 minus the first one, the 52.52503 degrees. So therefore, B2 equals, let me see, I'm getting 127.47497 degrees. That's the other option. See how that's more than 90? And this is less than 90? They're both options. They're both options. Now, you might say, well, why? Why do we do the 180 thing? Well, because when you're trying to solve this equation right here, sine of B, you're saying, where is the sine of B a positive answer? Well, think about the quadrants. Think about what we've learned about quadrants. Aren't there, if you do the quadrants, all students take calculus, right, where the different functions are positive. Notice in both the first and second quadrants, sine is positive. So what angle B is got a sign that's positive? Well, there's going to be one answer in the first quadrant and another answer in the second quadrant. And how we get the second quadrant answer, remember when we did those formulas earlier in the class? It's going to be all the way to here, which is 180 or pi, back up. Now, whatever the angle is in this quadrant, it's going to be the same angle there. You just have to back up that amount. So whatever the angle is there, it's going to be the same thing in the other quadrant, 180 minus it, to find that angle. That's the same, it's going to have the same sine value, right? Because sine is the height. Sine is the height on the unit circle. So whatever the height is in the first quadrant, you're going to have the same height in the second quadrant, where sine will also be positive. And to find the angle, it's a matter of going, the angle is actually from 0 all the way to there. That's the other angle, which is what? All the way to 180, back up whatever the original angle was up. That's why it's 180 minus the original angle. That'll give you the same spot in the second quadrant. So that's our second angle, 127.47, blah, blah, blah. So let's come back here. 127. I don't know how far they want me to round. Oh, just to 1. It says round these to 1. So 127.5 degrees. The other one was, I already forgot, 52.5, okay. The other one was 52.5. They want this, B1's the acute, B1's the smaller one. Okay, so there we go. round these and all remaining angles to 1 decimal place. Okay, now that means there's actually 2 options for little b. Little b can be 52.5 degrees, or this is going to be B1, or there's a whole nother triangle that's possible where B2 is 127 degrees, meaning it's more like this kind of triangle. Whoops, I was not using the right tool there. Let me try again. Like that. You see the other triangle has B2 here. Here's A, here's C. They're still the same angles they were. And here's little c, little a, little b. Little b is still 241.1. Little a is still 186.2, right? Little a, capital A angle is still 37.8 degrees. All that stuff is the same. But now B2 here, oh, did I write B in the, what am I doing? I'm being so crazy. Sorry about that. I wrote B where C was, didn't I? That was completely wacko. Let me try that again. I gotta look a little more carefully. Okay, so right here, this is not B, and I'm going to have to back this up. There we go. Okay, B, oh no, that is B. What am I doing? Oh, I'm getting so confused. That is B. That's B. It's all good. Let's go forward again. Okay, so I'm going to draw that again. Sorry to hold you up here. This is B. Oops. This is B. It just confused me to see this angle mark. I shouldn't do that angle mark here. There we go. So that's going to be B1, and I'm going to draw the other triangle again, like I did before. That didn't work so well. Okay, so this is now B2 here, isn't it? And B2 is a bigger angle. It's 127.5 degrees. And then all the rest of the stuff is still as it was. This is still A here, and this is still C up here. And the sides, little b, little c, little a, and they're still what they were. 186.2, little b, 241.1. All right, back in business here, and little a is 37.8 degrees. All right, so that's the second triangle. We actually have 2 triangle options. The 2 options for angle B lead to 2 different triangle options that are going to therefore have different C with C or C with C's, aren't they? And so they want us to find those different C's. You see? Sorry, I'm just joking around here. So this is C1, C1. This is going to be C2, C2. So here we go. Let's find triangle 1 first off. So coming on down. In fact, let me just add a page right here where we can see it. Okay, so I'm going to do triangle. This is step number 3. I guess 1, 2. This is step 3 here. So I'm going to do triangle 1. And I'm going to find C with C. How am I going to do it? Well, you find angle C by the total 180. Angle C1 is 180 minus the other 2 angles. 37.8 degrees plus 52.5 degrees, right? So angle C1, take your calculator. Let's figure that out. I'm getting 89.7 degrees. There's angle C1 because a triangle has to total 180 degrees. So now 89.7 degrees. This right here is 89.7 degrees. And now we can find side C1 by law of sines. So what should I use in here? Well, it'd be nice to use B with B because we had both those from the beginning, and they're not rounded numbers, right? We had B. Oh, no, we had A with A, didn't we? Yeah, my mistake. I'm going to use A with A. I like to use originals because they're not rounded. I'm going to use A with A because they are originals and not rounded. So A with A, and then C with C. A with A, C with C. So I'm going to say, okay, A with A, C with C. I'm going to go A over sine A is C over sine C. And I know A is 186.2 over sine of capital A, which is 37.8 degrees, equals C, which I'm trying to find, over sine of C, which I now know is 89.7 degrees. I got it right there. Okay, so you know the drill here, right? Diagonal, diagonal, cross multiply. 186.2 sine of 89.7 degrees is little c sine of 37.8 degrees. Last step here. Well, here, let me just divide by the sine of 37.8 degrees. Boom, boom. So we'll get it. Little side c there will equal this, whatever this comes out to be on our calculator. 186.2 times the sine of 89.7 divided by the sine of 37.8. I'm getting 303 point, how far does it want it rounded here? Round these remaining to one decimal place. Yeah, you look right here. To one decimal place. Okay, so I'm getting 303.8. So 303.8. So that's 303.8. Angle C was 89.7 degrees. Right? And then, so that's triangle 1. That's the conclusion of triangle 1. Now, right, we got all that. We get there. Now let's go to triangle 2 and finally finish this very long problem. So triangle 2. So that's step whatever, 4. Yeah, 4. Going to do the same thing with triangle 2. So we're going to first find angle C2. So down here we found C2. This is C2, I should have said, huh? So now we're going to find angles. No, that was C1. I'm sorry. This problem is too much for me. C1. This was C1. All right, C1. That was C1. Now we're doing C2. So angle C2 is going to equal 180 minus the other two, because there's always 180 in a triangle. 37.8 degrees plus 127.5 degrees. So angle C2 is 180 minus. I'm getting 14.7 degrees. So 14.7 degrees for that. And then finally, side C2. Again, we'll do A with A. So we're going to do little a over sine A is little c2 over the sine of angle C2. So what's little a? 186.2 over the sine of capital A, the sine of 37.8 degrees, equals little c2, which is what I'm trying to find, over the sine of angle C2, which I just found right here. All right, let's solve it. Diagonal, diagonal, cross multiply. 186.2 sine 14.7 degrees is little c2, sine of 37.8 degrees. Let's finish solving for c2. Divide by sine of 37.8 degrees, sine of 37.8 degrees. Boom, boom. Little c2 is alone. It's going to be all of this on our calculator. 186.2 6.2 times the sine of 14.7 equals divided by the sine of 37.8. Make sure you're in degree mode. 77.1. Oh, it was 09, so it rounds to 77.1. They said 1 decimal place, 77.1. There we go. All right, what in the world happened on this problem? Well, we just started doing our normal law of sines solving, and we realized there were two options here for angle B. The second option comes from doing 180 minus the first option, right? Two options for B. B2 is 180 minus B1, you see. You got to check that second option. There's not always a second option. A lot of times when you try the second option, the other angle will end up more than 180, and that's not possible, right? All three angles in a triangle have to total 180. But in this case, the other angle was a valid option. So we had two angles, B1 and B2. That led to two possible triangles, triangle 1 and triangle 2. Right? These B1 led to this triangle, B2 led to that triangle, and so then we used law of sines to solve for the remaining parts of the two triangles. So the moral of the story is there's two possible triangles that fit these initial conditions. There's two possible triangles that have capital A, little a, and little b that they specified. There's two possible triangles that fit that, and we found them both.